We have this another easy question given a binary tree, and what you need to do is you have to check whether root till or whether from root to leaf there exists a path whose sum is s basically. Just remember that it is given root to leaf. So what you need to check is if you'll start from root, root, does there exist a path till leaf? It should end on leaf that the sum gets up to the number what you are provided. For example, if we have this tree and I'll provide you sum is equals to 7. So you have to check, does there exist a path from this root and how many leaves are there? 1 leaf, 2 leaf and 3 leaf. Does there exist any path which can make sum 7? So of course this is the path which can make sum equals to 7. 1 plus 2 plus 4 will be 7. So yes, there exists a path. So we need to return 0 and 1. Basically it's a boolean. So the most important thing we need to remember is that we need to check only on leaves. Like it should be a leaf node, and for this to get true basically the sum should be equals to 7. So instead of summing up all the nodes, for example we are traversing this way, okay, so instead of summing of 1 2 5 and checking is it equals to 7, what we'll do, we'll take the reverse approach, and with every number we'll subtract it from our sum. So my sum is equals to 7, so I visited 1, I'll subtract 1, so my sum will be 6. Now 1 is visited, I'll visit 2, so from 6 I'll subtract 2, 4 will be remaining. Now I'll visit 4, from 4 I'll subtract 4, 0 will be remaining. So what we need to find is we need to find the 0, that if at any leaf, if at any leaf we have our sum equals to 0. So what are the two conditions we can clearly see for our program to be true? It should be a leaf and sum should be equals to 0. If sum is equals to 0, and it should be a leaf. If either one of them goes false, for example, if the current node is not leaf but the sum is 0, this will not be considered. Another thing is it can be leaf but the sum is not equals to 0, so it will not be considered again. And if both are false, then so it is obviously false. So the only condition we are playing is sum should also be equals to 0 and it should be on leaf. So there is a beautiful way I found in some articles to write them. Like what I was doing, I was just you know writing that if and else statement. If sum is equals to 0, first I wrote this, if sum is equals to 0 and my root is basically null, there is no next root, so then return true. Then I wrote another condition, if sum is equals to 0 and but my root is not there, but my root is not null basically, then it is false. Then I wrote another condition, if root is there but my sum is not equals to 0, my sum is not equals to, then it is false. So instead of writing all these three, I found a very beautiful way of writing it. Just see it. If I am standing at root, I am standing at a root, I am standing at a leaf node basically. This is a syntax. This is a syntax of leaf node, that if there is no further node in left or right, you need not to check root left or root right. We check in this way, na, root left and root right. You need not to check. This is the only syntax you need to check if it is a leaf node. If this condition is true, what you want me to do? What I want you to do is return now. Again we'll use smartness. We need to we need to check two condition. First one is it should be leaf, second one is sum should be equals to 0. So instead of using three if else statement, three if statement, basically three if statement, what we'll do, we'll use this return as a if else statement. What will pass if my sum is equals to 0. I will not write any if, because return itself is capable of providing me true or false whenever we put some condition in front of it. For example, I have put this, if sum is equals to 0. So whenever my sum will be equals to 0, what my return will provide me, it will provide me with true. But the only condition is this condition should also be true. If I'm standing on a leaf node, understand it again, if I'm standing, if I'm standing on a leaf node, and if my s is equals to 0, so instead of writing all these three statements, if my sum is 0 but if my sum is 0 and it is root, if my sum is 0 but it is not root, if my sum is not 0 but it is root, so instead of writing all this crap, what I did is, if I'm standing on a leaf node, it will say, okay, you are standing on a leaf node, what you want me to do. And if this is AND condition, what it will return, if s is equals to 0, which means if my s is 0, then return true. Once first for most, if I'm not standing on my leaf node, this will never get executed and I will never reach here. Okay, this is the beauty of this statement, that first we need to be at leaf node. After that, we'll be checking if s is equals to 0. Just imagine if s is not 0. So what, then how this will work? This will work like, I'll read it as, I'm standing on a leaf node, but my s is not equals to 0, so this will return me false. This will return me false. So if I got any false, what will be, what I'll think that, okay, I was on some leaf node, but the sum was not 0. Okay, uh, or what could be another condition, if root is equals to, if root is not null, if that is not leaf basically, so I will not enter it directly. How sorted is that? Like, I need not to check even, because our primary condition is that we are checking only for leaves. So if you are checking only for leaf, this is my primary condition. I hope this statement was clear. Then what I'm doing is, I'm passing the left and I'm passing the right with OR statement. Why I'm passing this OR statement? Because if either of them returns true, my whole function will return true. So I'm playing on them, that whatever you both will basically return. So if either of them return true means that I found a leaf where my sum got 0. So any of them return true, I'll just print true. So that's it for the whole purpose lies here, that how I'm tackling this. And these are the simple left traversal, right traversal, and waiting for values, like waiting for values using OR, that either I'll get true from left or either I'll get true from right. Thank you for this video.